So hello everyone, today we are going to start with day 2 of CATIA. In first lecture we have seen line command, how to make line vertical, how to make line construction, what are the toolbars for starting the sketcher, how to select the plane, how to exit the plane. We have also seen in last lecture how to constrain the objects. And today we are going to start with further commands such as rectangles, circles and many more. So to start with, I'm going to select the start key, say mechanical design, say part design, and in part design we can define the name here only so as to save the file. So I'm going to define the name as day 2, say OK. Now we are going to go for the plane selection. You can select the plane from model tree or directly from the screen by clicking on this plane. So whether you want to select front, top or right, you can select any plane for the sketcher. So I'm going to select front plane here, say sketch, and now in sketch we are going to go for rectangle command. So here select the rectangle, it will start from the corner, so it is a corner rectangle. Now to constrain the rectangle we need to give the dimensions, so we are going to refer this constraint toolbar here. In constraint toolbar we have this second option, that is constraint. Just double click and put up the dimensions required. I'm going to put the dimension between the sides of the rectangle, not directly on the line, because after you provide fillets on the rectangles, the corners will be removed and the length may get affected. That's why provide the rectangle dimensions in between sides instead of directly giving on line. Next, this vertical dimension, provide the dimension between sides only. I'll say it as 120. And now this rectangle is completely constrained. We can see the color is coming green, showing that object is completely constrained. We can also judge it by going on tools, sketch analysis, diagnose, and here we can see all the detailed information about lines and points showing the status as constrained. Say close. Next type of rectangle we are going to see here is oriented rectangle, and it is used for making the rectangles incline. So if you want to make any rectangle incline, you can use this rectangle, that is 3-point rectangle. Now to constrain this rectangle also same, provide the dimensions for the rectangle. Then we need to provide the angle also here, as this time rectangle is tilted. So we are going to provide this degree here. I'll say 25 degrees incline. Next we need to constrain it from the origin, as it is not made from the origin. So double click on constraint toolbar. I'll give one vertical dimension here as well as one horizontal dimension. So now as we have given the xy values, this rectangle's position is fully constrained. In this way we can define the rectangles if they are not made even from the origin. Next we are going to see here parallelogram. Now in parallelogram, the difference between rectangle and parallelogram is the angle between adjacent sides is not fixed in parallelogram. As in rectangles this angle is 90 degree fixed, but here we can provide any angle we want in between the adjacent sides. So this is the main difference between rectangle and parallelogram. So we will provide here the angle as 100, and next again horizontal and vertical measure from the origin. Just right click so as to orient it vertically or horizontally options. Next provide the side dimensions. So I'm not going to give the dimension on directly line. We are going to select the sides, then these two sides. Even then we can see this rectangle is not fully constrained. So the best option to understand why this sketch is not constrained, you just need to click on any point and drag the object or entity, and you can see the movement. If the movement is circular, such as in this case, we can say that rectangle needs to provide angle here. So we are going to provide the angle, making it constrained angularly also. I'm going to say 25 degrees. Now this parallelogram is completely constrained. Next we'll remove the entities from here. We'll go for the next command, that is slot, also known as elongated hole. So we need to make one line and just drag the mouse. It will be converted into slot. This radius will come by default only. You just need to change the value. We don't need to provide radius for the side arcs. I'll say this radius here as 100. Next we need to provide the center to center distance also here. So we are going to provide the center to center distance as 600 mm. Now this complete sketch has been fully constrained. Next we are going to go for cylindrical elongated hole. I'm going to delete this one. And for cylindrical elongated hole, select the option, select the center point as a first point, then will be the start point, and then will be the end point. You just need to drag the mouse then, and here you need to provide the side radius as it is coming by default. We just need to double click and change the value we require. Next we are going to go for the radius here. So I'm going to say this radius as 500. Now only these points are remaining to be defined or constrained. We can see this movement. Now to lock this movement for these endpoints, we need to make two lines here. I'm going to select profile toolbar again. Say both these lines, say hold and control. Select this option construction geometry. Now both these lines are being converted to construction geometry by using this sketch tools tab, in which we have this option that is constrain standard element. Now after making it constraint, as they are not required in geometry, they are just given for providing the angles. So I'm going to provide the angle here. I'm going to say it 45 degrees, and on the other side also I'm going to say the same angle, that is 45 degrees. Now both the lines are being constrained by the angles as they were drawn from the origin only. Now to stop this movement of this slot, we need to select the first endpoint and this line by holding the control key and then providing the relation, say coincide. Same way on the other side also, while selection we need to hold continuously the control key and then select the objects, then provide the dimensions or relations. The extra thing was this lines. We need to make this line so as to constrain the ends of the slot. Next we are going to go for the command that is keyhole slot. Now keyhole slot is similar to slot command only. You just need to click the first end, the second end, and from the second end we can see the whole slot has been coming here. But we have not put off this option that is construction geometry. That's why this object is also coming in construction geometry only. So we'll make it end the command here by clicking on escape key, put off the construction element off, and then go for the command. Select this slot again, start point, end point, and from the end point we can see the first end of this slot, and the second end of this slot will be slightly larger than the first end. You just need to provide the center to center distance. I'll say it 650 here. Next, the top side of the radius and the bottom side of the radius, we are going to change the values only. Now these three dimensions were required to constrain the keyhole slot, but still this slot is not constrained. It is because it was not made from origin. So I'm going to provide the dimensions from origin also, horizontal as well as the vertical dimension. Now this slot is completely constrained. So we can see the common pattern here. Whatever sketch you want to constrain, you just need to provide the dimensions of that particular sketch, maybe square, rectangle, slot, circle, and then we need to provide the dimensions from origin also if it is not made from origin. So this is very simple here. You just need to provide the dimensions so as to stop the movement of the part, and it will be completely constrained. Next command we are going to see here is hexagon. Now in hexagon, the other softwares provide number of sides for the hexagon, but in CATIA we can only make 6-sided hexagon. So I'm going to select the hexagon here. We can see by default the sides will come 6. You just need to provide the diameter for the hexagon here. So I'm going to provide the constraint as diameter. You can see the dotted circle with hexagon. I'm going to say this diameter for the circle as 1500. And now you can see this complete hexagon is been defined. Next command we are going to see here is center rectangle. So for center rectangle, select the command, say center rectangle here, provide the dimensions required. So I'm going to select the dimensions and provide the values here. We'll say 2500, and this vertical sides I'll say 2000. Now this rectangle was made from center itself, so it is a symmetric rectangle, and it is more useful than the corner rectangle as the sides will come symmetric by default only. Next we are going to go for this command that is centered parallelogram. Now in centered parallelogram we need to provide two lines first, and the sides of the rectangle will be parallel to these two lines. So we'll make them construction geometry as they are for only reference purpose. Then we are going to go for rectangle. Before that, just put off this option that is construction geometry and then go for the rectangle. Select the first line, select the center line, and the intersection of both the lines will be the center for the rectangle. Select both the sides first, then the other two sides, and then also provide the inclination angle. You can use this axis also as to provide the angle. I'll say it 45 degrees here. Next, one horizontal and one vertical dimension. Now still this rectangle is not coming constrained. It is because we need to provide the angle between sides also, as it is a kind of parallelogram only. So the adjacent side 90 degrees is not fixed here. You just need to provide the angle and then it will be constrained. I have taken 80 degrees here. So these were the commands related to rectangles here. Now after rectangles we are going to go for circle command. Start with circle. We are going to start it from origin. You just need to provide the dimension here. By going on constraint toolbar, we can also provide diameter or radius, whatever we want. We have these options here. I'm going to go for diameter. I'll say 4000 mm. Next circle, I'm going to make it a side only. We'll make it small and give this size as 2000 mm. But this circle is not fully constrained. But we can see here it has taken the relation as coincide. This constraint in green showing as 0 sign, defining it as coincide constraint. So it will not move vertically or horizontally. We just need to provide the dimension from the origin. So as to stop this horizontal movement, I will say it as 5000 mm. And this circle is completely constrained. Again, I will show how this relation has been taken place. You can see the dotted line here. It is passing from both the centers of the two circles. If I make this as a center point, we can see this relation again, it is coming, showing coincide with the origin, making it completely horizontal from this circle. This circle will not move vertically, it will just move horizontal only. Again, provide the dimension. From fully constrained object also you can provide, or from origin also you can provide the dimension. I'll say it as 3000 mm this time. Next, provide the dimension for the circle itself, 2900. Now, I will say this line command as a profile tool. Select this line from here and add this line here. We can see here this tangency relation has been taken place. Here also say control, select both the circle and line, go for the relation as tangency. Next, this line, making this line a circle constraint by going for tangency. Here also again tangency. Next, we are going to trim the extra entities here. Now for trimming, we have this operations toolbar, and in operations toolbar, in this third number option, that is trim, just click the drop down arrow and you can see the quick trim command here. Just double click on this command and we can see by clicking it, it will get trimmed here. The extra entities will be trimmed. So in this way, you can use this trim command also in operations toolbar, and we have this complete profile now. Next, we are going to go for this option, that is 3-point circle. First point, second point and third point. The other type of circle we have here is circle using coordinates. So I'm going to select one coordinate here. I've selected this origin only as a coordinate. We can select other coordinates also. Next, we need to provide the horizontal and vertical dimensions, and then lastly we need to provide the radius. So here I'm going to say horizontal dimension as 5000 mm, vertical also as 6000, and here the radius I'm going to take is 900. Say enter, and we can see this 5000 and 6000 mm as coordinate dimensions, and the circle is been placed according to this coordinate values with the radius as 900 mm. Next, we have this circle, that is circle by using tri-tangencies. So here we can say this first tangency, this as a second tangency, and this as a third tangency. So now one circle is been made having tangency on all the selected 3 points. So this is tri-tangent circle. You can also make it in rectangles. For example, if I take this corner rectangle here, then go for this tri-tangent circle, first tangency, second and third. We have this tri-tangent circle here. The size of this circle will depend on the width of the rectangles. You just need to quick trim it here, double click and then quick trim for continuous trimming. We have this profile now. Next type of circle we are going to see here is 3-point arc. So in 3-point arc there are two types. First one is this 3-point arc, in which I am going to provide the first point here the second point in between, and then the third point. Here this arc is by default coming tangency. We can see these two parallel small lines indicating that this relation is tangent. Next, we need to provide tangency on the other side also. So in constraint dialog box we have provided tangency, say OK. Now the other side is also been made tangent. So here the order of this making arc is first point and second point in between only, and then the third point at last on this other circle. Then we need to provide the radius, the dimension for this circle also, making this circle fully constrained from the origin. This complete arc has been now fully defined. Next type of arc is same with the same name, but only difference is the placement of the points. Now this arc name is 3-point arc only, but starting with limits. So here if I go for this arc, I am going to say the first point here. Second point in previous arc was in between, but we are going to provide the second point on the other end of the circle, and the third point will come in between this time. Provide the tangencies on both the sides. Then go for the radius value. I'll say this radius as 8000. Next, provide the dimensions for this point also so as to make it completely constrained. Horizontal and vertical dimensions. Then we need to provide the object dimensions now lastly. And now the sketch is completely constrained. You also have one more option here to edit the dimensions, that is edit multi-constraint. Just click on this option and we can see whatever screen dimensions present are being provided as a list here. We can change any dimension value. So if I want to change this value here, you just need to select the dimension and then we can provide the changed value here in this box. I'll say 25000 and say OK. It will by default get edited here. That is edit multi constraints. Multiple constraints can be edited at one time only. After you select the dimension, it will be highlighted in orange color in this sketch, and then we can change the values here. Say OK. Now the difference between 3-point arc starting with limits and 3-point arc is, here the arc was started from this as a first point, mid as the second point, and third point at the end. And here it is start point here, end point as a second point, and third point is given in between. So this is the main difference here, that the third point is given in between here. Now the last type of arc here is center point arc. So whatever will be the starting point will be the center point for the coming arc. Then second point will be the start point and third point will be the end point. So it is like center point, start point and end point. You just need to provide the radius here. It is over defining, as if the sketch is showing in pink color, means it is over defining. It is because it has taken the relation here that is tangent to this circle. That's why it is not getting any more dimensions. If I want to provide the dimensions, we need to select this relation tangency and delete it, and then we can go for the radius again. So I'll say this radius as 10,000. Double click and change the value. Next, we need to provide the end of this points, making it constrained. So for that, again we are going to make this profile lines here to provide the angles, and then making this point constraint on these lines. Select both the lines, make them construction. Select both the lines, make them construction geometry. Move line from the center to provide the reference angle dimension. Make it also as constraint geometry, and then go for the angles now. This I'll say 45. The other we are going to say as 35 degrees. Select the endpoint of the arc and line, say coincide. Same on the other side. And this arc is now fully constrained. So these were the commands we were going to see in day 2. We'll continue with the further commands in day 3. Till then, do like, share and subscribe the channel 4 Dimensions Infotech, and please support us so that we can make more videos on CATIA software and other upcoming softwares. Till then, thank you.